Okay, let's do this warm up real quick, and then maybe 4. We'll see. Okay, so number 1, it says find the solution to the following equation. Again, this is back to solving. You're looking for a solution. You've got an equation. You're trying to get x. What was the first thing that y'all did on this first problem? Distribute. Very good, because anytime we have a number in front of parentheses, or even though this isn't a number, what is it? It's not a written down number. What does it apply to be? -1. Okay, so if you want to write in the 1, write that in. If not, just know that negative implies that it's a -1. And so when I multiply it in, I get -2x. Next. Minus 7. On this side, I get 6 minus 3x. Okay. Any like terms to combine on either side of my equation? No. Okay. Not like terms to combine. So now I'm going to draw my line, and my goal is to get x by itself. So I want to get x on one side of the equals, the plain numbers, constants on the other side of the equals. It really doesn't matter which side you put the x or which side you put your constants. What did most of y'all do? Plus 3x. I think that's what I saw more. But if you did plus 2x, you should still get the same answer. It's just your sides are going to be swapped. But we want to move our x to the other side. So this will be a plus 3x here. And I'm going to add it to the -2x because those are like terms. And I did this last class too. I'm going to move 2 things at once, and that's okay because this is going to knock that out. So if I move my x's over here, then that means that my plain numbers, my constants, have to go over to the other side. Okay, so how do I move a -7 over here? Add 7. And you can do 2 steps in one time. It's okay doing that. Sometimes it will just save some space. So that's going to knock that out. So then I'm back to combining. -2x plus 3x is 1x. You have to put the 1? No. Could you? Yeah. Sure. And then this knocks out. And then 6 plus 7 is 13. And now, technically, what we would do if this was anything other than a positive 1, we would need to divide. But dividing by positive 1 doesn't change anything. So really, our solution is 13. Okay? So remember, what that means is that if you were to put a 13 in for x on both sides of that equation, you would get something true. If it's truly a solution, that's what would happen there. Okay? So that was kind of just a reminder. We did some solving last time. Here's more of what we learned last time. So we're going to do these examples. I'll help you with the first one, and then if you didn't get the second one, I'll give you a little bit of time to do that. And then we're going to go back and fill out this little graphic organizer thing, and we really only have 1 page of notes today, because then I'm going to give you a practice assignment. It's just, you know almost all of the exponent rules at this point. You'll know them all by the end of class today, and it's really just going to be about practicing these. And so I have like a little color by number thing that's got 8 or 9 problems on it, and so we'll work on those there. So it's not going to be as heavy as last time. I know we did a lot last class. We covered a lot of ground, but so if you remember, we have where'd our formula charts go? Didn't I have one? Is that mine? Did I not give you one?
No, you gave me one.
Oh, okay. I don't know what happened. Thank you. We talked about these properties of exponents. Oh my gosh, that's really, really bright. Maybe I need to get another one. Let me see if I have a lighter color. You can have that back. These fancy projectors, man.
Pretty.
I think this one. Let's see if, it says this is algebra 2, but it's okay. It'll work. So our properties that's better. Our properties of exponents are all here. So we talked about the product rule, which products are happening when we multiply. So if we have an operation where we're multiplying, our exponents are a step back, they end up adding. If we have a problem where we're dividing, we're getting a quotient, it's set up kind of like a fraction bar, our exponents are subtracting. If we have a power to a power, I called it the outside power rule, we multiply. Those are what we learned last time. Remember we said we're adding, subtracting, or multiplying. And then we also want to do that, and we always want to follow our order of operations, which is PEMDAS. So just to refresh, the exponent rule is your outside power rule, which means that has to go first. Outside power. And then your multiply would be your product rule. So that would be what I would do next. And then division would be your quotient rule. So as far as what order to do these, because order does matter, this is kind of the flow I would go. I would take care of any outside powers if there are. then I do my multiplications, and then I do my divisions, which we really kind of thought of as tug of war. So do I have an outside power on this problem? What is outside power? 2. So remember your outside power rule, you bring that outside power, you multiply it into every single exponent that is attached to. Now, do y'all see how there's a big parentheses right here? That means all of these guys are attached to the exponent of 2. So I've got to bring the 2 into everything, okay? But let's review a couple things here. What is c to the 0? What is anything to the 0?
Just c.
1. Not c.
It's
1, okay? So, and if you forget, remember you pick your favorite positive number and you raise it to the 0 power in your calculator. That reminds you it's 1. So the first thing that I would do is if I see any 0 powers, sometimes they're in there just to kind of make the problem look a little bit more complicated. And obviously see if you know that, but I would just take that out altogether. Like I don't even need to look at that because it's just a factor of 1. The other thing I would do is we want to make sure everything has an exponent. So the top A has an exponent, top B does, that C drops. What about this A? What should I give this an exponent of? I would go ahead and like do that little cleanup before I do any rules. Take out zeros, like completely, they're gone. And then add in exponents of 1 if they don't have one, just so you can like know what number you're looking for. And then we're going to follow our outside power rule. Which I'll write, we're doing our power rule first. That's number 1. And we're going to bring that outside power to all the inside powers. So those 2 on top, and then these 3 on the bottom. Okay? So what does that give me? I'm going to do a couple steps right here, because these, a lot of times you want to do in multiple steps. Brayden, not always in your head. Okay? So what do I get here? This is going to be a to the 4 times 2 is 8. B to the 4th power. Very good. And then C is gone. Okay. On the bottom, I'm going to have A to the 1 times 2 is 2. B to the 2 times 3 is. And then C to the 5 times 2 is 10. I'm just going to have that right there. Okay. That's my middle step. And again, it is worth it to take the time to fill that out. So I've taken care of the outside power. It's looking better now. Now I'm going to check, are there any products? Is there anything I can do to clean up the numerator at all? No. Anything I can do to clean up the denominator?
Nope.
No. And then now I want to look at my quotient. For my final answer, I'm going to do my tug of war between one base at a time, one letter at a time. Who's going to win between the A's, top or bottom?
Top.
By?
4 or 6.
By 6. Okay, because you have, remember, technically you're subtracting. 8 minus 2 is 6. And so I'm going to have A to the 6. I have 6 more A's on the top, so they win. Now I'm going to look at my B's. Who's going to win with the B's?
Bottom.
The bottom by,
2.
so I have B squared on the bottom. And now, is there anything I need to do with the C's other than just write it down? No, because I just have C to the 10th on the bottom, so it stays there. So this is my final answer.
I think the C won.
It did. It was competing against nobody. Okay? So it stays down there. So the next question is really similar. If you haven't done that, I'm going to give you a second to do that. But I want to make sure you understand what it's asking. This is saying, what is the value of, because this I think is kind of star. So they say the expression below is equivalent to m to some power, n to some power, p to some power. What are they asking you to find? Like if this was a griddable question, what would they really want you to look for? The value of what?
Z.
So it's really trying to figure out, okay, what is p's exponent? Its final exponent. That's what the question is asking. So simplify it all the way down like we just did that one, and then we'll talk about how to answer it. Ready, set, go. Been a morning. Okay, so did y'all get this when you brought in the outside power? Are y'all checking my math?
Yeah.
I'm a little bit frazzled right now. You good?
No.
No, you didn't get that? This should be M4.
Yeah.
There we go. N4P2. Yes?
Nope. Wait a
Still
minute.
no?
Yeah. Yeah, I got that.
Are we good? Okay. All right. So then now I'm going through and I'm going to do my quotient because there's no other products to do. So who wins between the M's? Top by?
4.
So M to the 4. Okay. So who wins between the N's?
No one.
Okay. It's a tie. So okay. So here's one thing that I feel like I heard yesterday happening quite a bit. Technically, if you follow your rule, when you subtract, what is 4 minus 4? If I follow my subtraction rule, 4 minus 4 is No, 4 minus 4 is 0. So this is really n to the 0 power, but what is anything to the 0 power? Actually, 1. So really, you can just mark those out because it's just a factor of 1. There is no longer an n in the problem, okay? So, like, don't write that in. You don't have to write a factor of 1. You could, but you don't have to. Who wins between the p's? Top by 4. Okay, so here's how you would answer this question. If I just said simplify, this would be your answer. But this question, again, and I could see them doing this on star, is they're saying, hey, what's the value of z? And so notice, z is the exponent. That's with the base p. What's the exponent with the base p? 4 in our final answer. So we would say that z is equal to, I make my z's like this sometimes so they don't look like 2's. Z is equal to 4. So that's how you would really answer that. Again, just the wording of the problem is kind of tricky. Ethan, did you have a question? What we did last time. So I want you to flip not to the 7.2 breakdown because this is actually not in the right spot. Flip back over. Sorry, now I'm all over the place. To page 7, the 7.1 breakdown. Page 7. And I want you to fill out your rules from your star chart for each one. The 0 power is not on the star chart, just FYI, so you might need to look at your notes. And then I want you to write an example, make up an example on your own for these here before we move into like our last couple rules, okay? So do that real quick. Again, I said just to write down the rules from the star charts, which I think most of y'all did. But like I said, with these, it's about really understanding like when to use which rule and which one they tell you. So I also like to be able to write this from the chart, but also describe it in words. So like I would say exponents add. Okay, so when I notice I have side by side, and pay attention, this is when they are side by side, or how else can we write a multiplication? We can do the multiplication dot, or we can do what else? Put them in parentheses, okay? Or just put them next to each other side by side. So that's when the exponents add. Quotient is when you have a, what I just draw? It's a division sign, but it also is like kind of like a fraction bar. So if you got a fraction, then that's when you're going to be thinking of subtraction. So I'm going to say exponents subtract, or a lot of times we do just our tug of war. Is it tug o or tug of? I don't know. Tug of war. Okay, and we kind of look at it there. Our product of powers is when we only have the base written one time, but there's an outside power. And what do those powers do? What do you do to the exponents? What do you do to the exponents? Right here. No. Multiply. The exponents multiply, and I call this the outside power rule. And then the 0 power is not on the chart, but the rule is technically that anything to the 0 power is what?
1.
1. Big number 1. So mark it out, get rid of it. And then I wanted you to do an example. You could just write a very simple example on your own, okay? So there's one more rule that's on the chart that we flip back forward now. There was our warm-up. One more page. Okay, this is the last page of notes we're going to do today. 7.2. Wonderful.
So it's like
Okay.
last page.
It's for today, yes. Okay, and then we have our practice thing. Okay, so we have our exponent rules. So there is one more rule, and it is our negative exponent rule. This is on the formula chart, but we don't like to have negative exponents in exponent land in math, okay? They're just not fully simplified. So if we have something to where either we do an operation and we end up with a negative, or we just put a negative in the problem, there's a quick fix for it. Okay, this is what the rule looks like. Now, this is on your star chart, okay? So if you look at it right here, it says a to the negative n is equal to 1 over a to the n. So I kind of want to explain what you do. And when I explain it in words, you'll realize it's not that bad, okay? So if a base is raised to a negative number, what do? you're going to move the variable, okay, or move the base with the exponent to the opposite side of the fraction, okay? So if your negative exponent and its base is happening in the top, then I'm going to move that guy to the bottom, okay? If it's a negative in the bottom, I'm going to move it to the top. So I just move it to the other side of the fraction, and when I do that, I'm then going to make, we're going to make the exponent positive, okay? So that's in words, and then let me show you how to do this on these couple examples right here, because it's really not anything super crazy. The expression is fully simplified when the variable shows up only what? Once. So you'll know that you're done. Okay, so here's 4 examples. So what I usually do is if I see a negative exponent, I circle it, because to me, I'm looking at that like, okay, there's a problem. And it's just exponents that can't be negative. Coefficients, regular numbers can be, but exponents cannot, okay? So circle that -2 right here. We don't want to keep that. Now, the other thing that I do is I kind of analyze, where is that in the fraction? Well, there's not a fraction right here, but how do I make anything into a fraction if I want to? Put it over 1. So everyone do that with me. Put that over 1. So right now, where is my negative exponent? In the top of the fraction or the bottom? It's in the top. But I can't have a negative exponent, so I'm going to do this. I'm going to move the base. Draw your fraction bar right here. What's the base that's attached to that negative exponent? What's the base? X. So I'm going to move the base from the top to the bottom. So I'm now going to move my x to the bottom. And then I'm going to make that exponent positive. Okay? Now, what's left in the top? What do I have to put in the top?
The 1.
A 1. If there's nothing left, you have to put a 1 on the top, but that's all I have to do. I'm done. Okay? So figure out in terms of, I know I can't have this, so I'm going to circle it. Where is it? If it's not in a fraction, put it in a fraction and then move it. Okay? Let's look at the next one. 1 over x to the -2. The fraction's already there. But there's a -2 exponent. I'm going to circle it because that's a problem. So I got to move it. I got to move the base x to where? Top or bottom? To the top. And when I do that, I'm going to make the exponent positive. Now, what's left on the bottom if I move that? Is there anything left on the bottom?
1.
A 1. But do I have to write a 1 on the bottom? No. So you can, but you don't have to. So really, you can just write that as just x squared. You have to write a 1 if it's on the top, but you do not if it's on the bottom. Okay?
Why do you have to write it? Why do you have to write it? I mean, at the top I get why, but like, why don't you have to write it at the top?
Because dividing by 1, anything divided by 1 will just be itself. So it's just like you don't write times 1 because it's just itself.
Yeah.
Okay? All right, let's look here. X to the -2, y to the 3. All right, I'm going to make that a fraction, so I'm going to put the whole thing over 1. Where's my problem? What can I not have? Negative exponent. Is there anything wrong with y? Y to the 3rd? No, because it's positive, right? So I don't have to move that. I only have to move what I circled. So I'm going to draw my fraction bar here. Let's go ahead and take care of the x. Where is the base x right now? Where's base?
Top.
In the top. So if it's negative, I need to move the base to the bottom and make the exponent positive. But what's in the top?
1.
What else?
Y3.
Y to the 3. Y to the 3 can stay exactly where it is. So it's like when you have multiple things going on, which you typically are going to have multiple things going on, you only move your problems. Everything else just stays as is. You could put a 1 in front of that y to the 3rd, but you don't have to, okay? So look here at this last one. How many problems do you have? How many things are you going to have to move?
3. Wait, no, 2.
Just 2, because what's a's exponent?
1.
1. So do this one. There's your 2 problems. Leave what's okay. Move and fix what's not. And the idea behind this is leave what's okay A is okay in the top. You don't have to put A to the 1. I wrote it in just so we could see it, but in my final answer, I can leave it. B is not okay in the top. So where's B going to go? Bottom with the power of positive 2. So make sure if you move the base, you got to flip the sign. And then C with the negative in the bottom is not okay. So C has to go to the top, get a positive exponent. Okay? And so here's your final answers on these. So that's what happens. And I think, Anya, you were asking last class when we talked about the subtraction. Okay? So we had a problem like, you don't have to write this down. I'm just going to write this somewhere. We had a problem where it was like, I don't know, x to the 3rd, x to the 8th. Okay? And you said if we did our subtraction, 3 minus 8 is a negative, right? So we would say this is technically following that rule. It's x to the negative 5. But now that we know we don't like to keep negative exponents, how would I fix that? Where would x to the 5th power need to go? At the bottom. And so that's why I said, like, when we talk about what happens when you get negative exponents, it'll make a little bit more sense. But that's why I also just really like the tug of war thing, because you can kind of see where it's going to go based on where there's going to be more. But technically, if you did your subtraction rule, this would happen, and then you would have to fix it. Okay. So that's kind of how all that relates. But don't leave negative exponents. I have seen one star test, I think like 2 years ago, that they did leave a negative exponent like in the answer choices, and that annoyed me so much. But for my class, we're not going to do that. We'll fix them and then move from there. So the last thing that we really have to do is just these 4 problems. They are going to take a minute and take a little bit of space. But everything we've been doing so far, all the rules, the product, quotient, outside power, negative, we haven't talked about any problems that have coefficients in front. What is a coefficient? It's a normal number next to the variable, okay? So we're going to bring these into the problems we're going to see today. But here's what I need you to understand. Coefficients are normal numbers. Therefore, what does this say here underlined? Normal operations. So that means if you have a multiplication problem, the coefficients will multiply. The exponents are the ones that have the weird rules, because those are different types of numbers. So normal operations with your coefficients always. So it is a little bit trickier. You really got to understand what's a coefficient and what's an exponent, okay? So we're going to go through a couple of examples, and then I've got some practice for us, and then we'll call it a day. Next class, I don't think I've showed y'all the calendar yet, but next class the plan is, let's see, current unit. The plan is to have a mixed practice day, so not really any new material. We'll just kind of review what we did, do some stuff together, and then we are going to take a CFU by the end, okay? So really all new material is happening today, and then next class will just be like review and practice, okay? Because that's the thing. These just need a lot of practice. Tuesday will be an 8A, yes, okay? So it'll be just like this week. Yeah. Start with a 8A, okay? All right. Do we need a little brain break before we do these 4?
Yes. Yep.
Small brain break? Small, like,
Big.
okay, here we go. Let's do some math problems here, okay? We only got 4. But we got to talk through these. So the first thing with these types of problems is to really just, like, number 1, don't get overwhelmed. Number 2, just look at it. You've got to think what rule, like what is happening with these problems. Do I have an outside power is kind of the first thing I check. Okay, and if you do, take care of it. If you don't, move on. Am I multiplying or am I dividing? And then I'm just going to work one thing at a time. Coefficients, base 1, base 2. So it's like you kind of have to like really structure it in your brain to where you're not just like, blah, there's numbers and letters everywhere. Think of it like one task at a time. So let's look at this first one here, okay? Negative 5m squared into the negative 8, parentheses, 2m to the 3rd into the 2nd, okay? We are not going to go to the answer blank just yet. We are going to take some space on this because most of these involve quite a bit of work. Are there any outside powers? That's the first thing I want to check for. Any outside powers on either of these? No. Okay, so I don't have to worry about doing that distributing thing. Not on this one. Does everyone understand that? I'm looking up here. There's no outside power, so I don't have to worry about that now. Okay? Miles, put your shirt down.
I have a phone.
Why do you have a phone case? No. Okay? So there's no outside powers. Now, what type of problem is this? What operation is implied when I have side-by-side parentheses? Remember,
Definitely.
your operations are addition, subtraction, multiplication, or division.
I think it's gonna be multiplication.
This is a multiplication, so I'm going to put a little PRO for product rule, okay? Okay, this is a product problem that I'm trying to do. All right, now I'm going to go and I'm going to kind of underline. Do I have coefficients on this problem? Big numbers, regular numbers. Do y'all see coefficients?
Yep.
What's the first coefficient?
-5.
-5. Underline -5. What's the second coefficient? And the other guy? 2. Does everyone besides Anya understand that?
Yeah.
Okay, our regular numbers. Regular numbers follow regular rules. Say that. Regular numbers follow regular rules. This is a multiplication problem. So y'all tell me, what is -5 times +2? -10. So put a -10 right here. We've simplified the coefficients. We're done. Now, let's move to the letters. Nick, you with me? Let's move to the letters. The first letter is
Definitely an M.
M. So I'm going to underline my M's 2 times. Okay? Just to help me focus, I'm focusing on the M's. Now we're in exponent land. Okay? Exponents have different rules. And your formula chart reminds you that when you have a product with exponents, what do the exponents actually do? I'm pointing to it. M plus N. You add. So do what we did last class. What is the next base? Next base was M. 2 plus 3 is 5. Okay? What's the last base we're going to look at? It's the last letter. N. Write it down. Into the -8, into the 2. We're still adding. But what is -8 plus 2? -6. Okay? Is this my final answer? No. It's close, but it's not my final answer. Why? Where is the problem?
Because you have a negative exponent.
I have a negative exponent. So circle this -6 right here. Everything else in this problem is okay. Is 10, it's negative, but is that an exponent? No, so we don't care that that's negative. That's fine. M has a positive exponent, so that's fine. It's N, that's the problem. So where is N right now in terms of the fraction?
Negative.
It is negative, but where is it's at the
Top.
It's at the top. So for my final answer, I'm ready to move to my final answer blank. I'm going to leave the -10 at the top because there's nothing wrong with that. I'm going to leave the M to the 5th at the top because there's nothing wrong with that. But where am I going to move the N? To the bottom and make it positive. There's my answer. And make sure y'all can see that fraction bar there. Okay? Are we okay?
Yeah.
You too. Are you with me?
Huh?
Are you with
Yeah,
me?
no, I still got to write that.
Well, let's write.
I think you zoned out.
Okay? It's not a good day to zone out. Okay? All right, we did one. We okay?
Yeah.
Let's try another. Let's try the one right below it. All right, remember my checklist. Do I have any outside powers here?
No.
No, I do not. Is this a multiplication problem?
Yes.
Yes. Wait, no.
No, it's division.
It's a division, so I'm going to use the...
But you got to do multiplication.
I do have to do multiplication?
Wait.
Is this still a real number? Oh, no, my
Oh, no, we're going to do just division with these, okay? So I'm going to put a QUO for my quotient rule, okay? I'm going to use my quotient rule here. And I'm going to go one thing at a time, okay? I'm going to even just cover this up. Now, do we have coefficients in this problem?
Maybe.
What's my coefficient on the top?
It might be.
Coefficient, big number.
3.
3. What's my coefficient on the bottom?
5.
5.
Wait, oh, I was looking at the one above it.
Okay.
9.
9. Okay? Do you see how I just circled those? Regular numbers follow Regular rules, okay? So I'm going to go here. I'm going to draw myself a fraction bar in the middle so I can take my time on these. And what I'm going to do, what I suggest for these when you're using your quotient rule, is put those regular numbers in alpha y equals in your calculator. Because we want to simplify. Now, they may simplify to a whole number. They may just simplify down to a fraction. So let's put our regular numbers, 3 over 9, in alpha y equals. And what do we get? 1 over 3. Okay? Regular numbers, regular rules. Do the math. Boom. Done. Done with the coefficients. Now, I'm going to go one letter at a time. What is my next base?
Definitely the D.
D. Okay, base D. And since this is a quotient, I am no longer adding my exponents. What am I doing? Subtracting or tug of war. So who's going to win, top or bottom, with base D? Bottom by
6. 2. Wait.
Are you looking at the same problem I'm looking at?
Am I?
I don't know. There's 4 D's on the top, 6 on the bottom, so the bottom wins by 2. Now look at your E's. This is what we did last class. The only thing that's different today is coefficients. Who's going to win between the E's, top or bottom? Top by 3. Okay? Now, I'm going to write this without putting the 1 at the top because I really don't need it. Here's kind of the fully simplified answer. It's just e to the 3rd over 3d squared.
I was looking at 9 minus 3. I was thinking 6.
Oh, yeah. So that's the thing, though, is people try to, apply the exponent rules to the coefficients, and those are not the same. These rules that we've been going over, add, subtract, and multiply, those are only for the tiny numbers. The big numbers, they just do their normal thing, okay? All right, let's actually try this 36 one right here before we do this next one, because this one has kind of got more steps here. And then, like I said, we're going to go to practice and we're going to work, okay? Because me doing a million trillion of these is going to do you nothing. You got to practice them on your own. All right, so the bottom one, are you with me on this one? 36, x to the negative 4, y to the 8, to the 1/2. Is there an outside power? Yes, so I'm going to write OP. That stands for outside power. And my outside power rule is do what with your exponents? Distribute them. Remember, it's right here. Power to a power, they multiply. Now, here's what's kind of tricky when you throw in coefficients. Look at me. Look at me. You cannot multiply an exponent to a coefficient. That is not allowed. Okay? Those are not the same. What's a coefficient? The big number, the regular number. What is the coefficient here? 36. 36. Okay? So what my suggestion would be, if you have a coefficient in an outside power problem, what is the coefficient's exponent? If it's missing 1?
1.
Write in a 1. So now, write that in. If you didn't do that, write that in because this is a big common mistake. So now I'm going to multiply my outside exponent to every single inside exponent, including that 1 that I just wrote. Okay, and we're going to take 2 steps to finish this. So write that in, give everything an exponent, and then you multiply it that many times. Okay?
Quick question. What does the OP stand for again?
Outside power. Outside power. So now I'm going to write, okay, my base is 36. What is 1 times 1/2? 1/2 or 0.5. Okay. The next base is x. What is negative 4 times 1/2? Y'all got calculators. Pick up a calculator and do something. Negative 4 times 1/2 is what?
-2.
Thank you. What is 8 times 1/2?
4.
What is multiplying by 1/2 the same thing as doing? Dividing by
4.
2. Divided by 2. Okay. So now I have 36 to the 1/2, x to the -2, y to the 4. It's not fully simplified as my final answer. Are we all okay getting to here using that outside power rule? Okay.
I have a quick question. So, for the 1/2 to the 36,
36 to the 1/2, we're going to put it in our calculator.
okay.
That is a number, okay? All right, so everyone get your calculator. Here's how we're going to clean up this little piece right here. 36 is a number base, so we can actually raise that in our calculator. You with me? Okay, so 36, and you got to remember the little caret button that gets you an exponent right here? Press that. And then how do you get a 1/2 power?
The decimal is 1/2.
Alpha y equals 1/2. And then press enter and tell me what that gives you.
6.
And then right now, all this is in the top. 36 to the 1/2 is technically the same thing as taking the square root of 36. Okay? Now, what else do I have to do to simplify that problem? Do I have any other issues? I see an issue.
Negative.
You can't have a negative exponent. No, no, no. We can't have that.
Bad.
So where does x gotta go?
Hello, down.
Bottom.
Downstairs. And its exponent becomes
Positive.
positive.
Wait,
Okay.
I'm confused. Why does it come
Oh, and
from
then do you just put y?
So
Y
when
for-
you move the base to the other side, that like flipping it to the other side flips the sign of the
And then
exponent.
do you
How
put
do we
y4
even
at
get
the top,
y2
right?
for 36?
How did we get,
y2 for 36.
what do you,
We didn't.
What are you talking
we got
about?
6.
36. It's the square.
I'm talking about y2.
Oh, like right above the 36?
That's a 1/2. That's a 1/2 power.
Oh,
Because I gave 36 an exponent of 1. Oh, I'm sorry. I just didn't understand what you were saying. Now I see it. I multiplied, because remember I said you can't multiply an exponent times a coefficient. So I have to give 36 an actual exponent to deal with. And then I multiply in the 1/2 times 1. 1/2 times 1 is 1/2. Okay? I'm sorry. I understand what you mean now. Okay? And so 36 to the 1/2 power, I use that in my calculator. And then this is my final answer right here. Okay? So do you see what I mean about you kind of got to attack these like one rule at a time, one simplification at a time, like, and it makes it a lot easier if you kind of break it down like I've been doing. Deal with the coefficients, deal with the first letter, deal with the second, and then it's not as bad. Okay? So this last one, there's 2 rules we're going to do, but what is the first rule that we have to do? Our outside power rule. So we have to do step 1. We got to do our outside power. OP as I write it. Okay, because the first parentheses has an outside power. This also, like, listen here real quick. Outside powers are only attached to what's in that parentheses. So this power of 2 is only attached to the 6x to the 4th, y to the 5th. It's not attached to this second guy right here. But what do I have to give 6 an exponent of?
1.
Write that in. So how many distributing am I really going to do? 1, 2, 3. Okay? So let's do that together. So that first base is 6. 1 times 2 is 2. 6 to the second. I'm going to clean that up in a minute. Now, take the 2 to base x. 4 times 2 is base y. 5 times 2 is 10. And then I don't have an outside power on this other guy, so I'm just going to write it. -2 x squared. I'm probably going to go ahead and give that y to the 1. Like that. Sorry, there's not a lot of space. Okay. What is 6 to the second power, though? What number is that?
To the second power. Oh, that's 12.
Put it, no.
Oh, wait, no. It's hold on.
6 caret 2.
Because it's 6 times 6.
36. So let's rewrite that. I'm going to mark that out and write 36 right there. Okay. What's the second rule I'm going to use here? Now that I have it like this, what operation is happening? Are they dividing?
No.
Are they multiplying?
Yeah.
So I'm going to use my number 2, my PRO product rule. Okay? Because it was 6 to the second power, And if you put that in your calculator, 6 to the second power is 36. Remember, you're not multiplying. It's 6 to the second power. It's 6 times 6. Okay? Isa, you with me? Okay? All right, now I've got to go through and do my product rule. Regular numbers follow regular rules. What are my 2 regular numbers here?
36.
2 and 36.
What kind of 2?
Negative.
Negative 2. Is that a problem that it's negative?
No.
No, because it's a regular number. So what do I do with 36 and negative 2?
Multiply.
Multiply them. What is 36 times negative 2?
Something high. Negative.
Negative 72. There's your coefficient. Coefficient is done. Donezo. Now move to exponent land. In exponent land, when you multiply, you're really doing what with the tiny numbers? Adding. So x is going to be 8 plus 2 is 10. So then what's y's power?
Ooh, y is,
Why is it 11?
I don't know that actually.
10 plus 1.
Oh, okay. 11.
Okay. All right. So while I am passing out the practice for us, which there are a couple of mistakes on there that we need to fix. So I'm going to come pass this out to you. Keep your notes out because you're probably going to need some examples. And then we're going to work. I'm going to put my notes to the side. Keep your notes to the side. But yes, you're going to do this page last. So I want you to do all the problems first. So here's the problems on the second page. There are only 9. Okay. And again, they're kind of complicated looking. So you just got to attack it one thing at a time. I can help you. But here's the problems. What's nice is that the answers once you get an answer, look for it over here. If it's not over here, then that means you did it wrong. But everyone go to the color key because there are 2 mistakes on here. So if you don't fix these, then it's going to be confusing. And that's our bad. Okay? All right, go to color dark green. Dark green color. Go to that answer real quick.
Yeah.
Everyone find that?
Like the
It's
fifth one
16. Yeah. 16a to the 16th. It's not supposed to be b to the 24th. Okay, so mark out 24. It should be b to the 22nd. Yeah, make sure you're writing this down because otherwise it's going to confuse you. Okay, so dark green, everything is right except for it should be b to the 22. We good with that?
We good.
B to the 22. The next one is color white, the second from the bottom. This is a quick fix. It should be x to the 2nd, not x to the 3rd. So sorry. But everything else should be good. X to the 2nd, y to the 7th, z to the 6th. So what's nice about this, like I said, is once you make those 2 corrections and you get your answers, they should be listed over there. And if they're not, then that's when you say, hey, I did something wrong. I need help. Okay? The first 4 problems don't have coefficients. So this is really what we did last class. The bottom 4 problems do have coefficients, so be careful with those. But we also put a lot of 0 exponents on there. Remember, anything that's attached to a 0 exponent is just a...
So we have to actually color.
Mark it out. I want you to get the problems done first before you color. Okay?
I don't need to color.
Okay. Do what?
Do you have colors we can borrow afterwards?
I do have colors you can borrow when you're done. Okay? And I have an answer key too, so I can check and I can help. Hey, we're working. Let's go. 1, 2, 3, go.